are here at CapEx to support you. Like I mentioned on every call, we don't exist without our customers, so we are very appreciative. My name is Russ Sorrells. I am one of the team members at CapEx. Today we've got Aaron Alberts with us. He is from Sciemetric, and we are going to talk Industry 4.0. So we're going to have kind of a Q&A, high level. What is, first let's talk about what is Industry 4.0. It seems there are multiple definitions out there, so understand it conceptually, and then talk about some of the steps that customers can take depending on their manufacturing operations to start to implement Industry 4.0 in their facilities. So we're going to talk through some of that kind of step-by-step conversation. We've got a few slides to go through. So Aaron, tell us a little bit about you, where you're from, and what you're up to these days, besides staying in your basement.
Yeah, besides staying in my basement. So Aaron Alberts, I work for CTS Sciemetric. I've been with the company for 5.5 years now-ish. Grew up here in Michigan. I'm in Michigan now, just outside of Detroit. Grew up here in Michigan. Got my mechanical engineering degree from Western Michigan, and I've been working now in the test side of the manufacturing space for about 15 years, 16 years, I guess. I'm losing track of time because, in quarantine, right. everything's a blur. So I've done a lot of different things. I've seen a lot of different, been in a lot of different roles, from design and like actual hard engineering into project management and capital equipment purchasing. And, I think when I came to Sciemetric, I was really intrigued by some of what the company was able to do. And particularly because I had struggled with things that, as an engineer, there were things I was working on, especially in the test space, leak test, hot test, whatever the case is, that if I had just had access to a little bit more data, I think I could have made some smarter decisions. And at the time that, 15, 16, 17 years ago, Industry 4.0 wasn't a thing. Oh, yes, my children are going to be in there. You're in the camera there, babes. So, now as we start to think about Industry 4.0, and it's a term that's been out for a few years now, I'm getting particularly excited about the possibilities that exist for being able to take some of the data that now exists and put it to use. So that's a little bit about me. Pretty average guy. You can see I have 2 children. You've seen them both since we started talking. There's another one. Oh, you started sharing. Okay.
Yeah, I just wanted to go ahead and share this screen. So for sure. Well, thanks for that. Thanks for that intro, and no problem on the family. I mean, I think that's awesome. More fun, I think, is that we get to know people at a different level. We see people in different environments. I'm in a cabin right now in Wisconsin, fishing. Well, I'm not fishing right now, obviously, but up here, my family for 59 years has come to the same lake in Wisconsin fishing. So right or wrong, I was not about to miss it this year. So we holding strong on our 59th year of fishing in Wisconsin. So it makes it more real. We get to see people or meet to see people in a different environment and get to know each other in a different way than we never would before. So. Well, let's hop in and let's show this. I'm showing this slide that you had sent over to kind of talk through some of these guiding principles of Industry 4.0.
Yeah, so Industry 4.0 is a really interesting time. It's Industry 3.0 was sort of the revolution of fully automated manufacturing. Robots, were the big step in Industry 3.0, Factory 3.0, whatever you want to call it. And robots continue to play an important role in the workplace, obviously, as they advance. But Industry 4.0 or Factory 4.0 really is meant to center on the capacity to to do a couple of things: to gather data from places that didn't used to produce data, connect devices to to each other in some cases, or to you in other cases, so that you can start to use the data that those devices are producing to help you make better decisions. And at the end of your manufacturing process, what you hope to have is a digital record, a birth history record, we call it, for that part, which comprises everything that happened to it all along the way. You know, every test that it undertook, every manufacturing process that was imparted upon it, so that you can not just have the data at the time that you produce it, but keep that data so that you can look back on it. If you were to have any sort of problem with the part, you could look back on it and help to start to understand if there was something you missed, right? Having access to that data and being traceable in that way, according to serial numbers and model numbers and dates and times. That's all part of Factory 4.0. And the goal of all of this, of course, is improvement, continuous improvement. We don't want to just collect the data for the sake of collecting data. It's expensive and not productive. So
there's a lot of that going on these days too, right?
There is, yeah. And it's, Factory 4.0 is something that everybody is sort of being asked to manufacture with that in mind now. And, as people are challenged to do that, they want to meet those challenges, and they want to implement tools that sort of fit into what their belief is as far as Factory 4.0 goes. And what you can end up with sometimes is a lot of data that you don't know what to do with, right? So, and that's not the goal. The goal is to try to approach it in the same way that you would approach any other manufacturing process, in a stepwise, methodical fashion. And like I said, the goal of all this is to be able to use that data to do the things that are on the right-hand side of this slide,
What are you seeing as some of the biggest challenges as you go out and work with customers? What are some of the bigger challenges that they are experiencing, and how are you addressing those challenges?
I would say some of the biggest challenges are with regards to legacy products. So,
And legacy products?
Yeah. So legacy products, we would consider, things which were purchased for the manufacturing environment before any of this stuff was ever really conceived. So there's a lot of operations, leak testing, press, crimping, you name it. There are a lot of operations that people do as part of their normal manufacturing process that can be done either in a Factory 4.0 ready way, or depending on when that equipment was purchased, not Factory 4.0 ready way. And so we have a lot of customers that approach us with, even some of my largest customers, the equipment they put in is 20, 30 years old, and it's still going strong and it's working great, but they realize that it no longer, or at least at the time it was put in, it wasn't really thought through in a way of like, well, are we going to need to collect data from this someday, right? It's mostly just, did it pass or did it fail, right? And that can be a real hurdle for people as they look at what Factory 4.0 is meant to be, and what the finished product of Factory 4.0 is meant to represent. They can feel disenfranchised a little bit because that's not what their manufacturing floor looks like right now. And so finding that entry point, where do I start? That can be a big challenge for them. So
and that's the mission. So the mission is what you've got over here on the right side. So value on the production line, right? So when you say that vision for the end, it is no defects escape the factory. We're going to miss processes, and then fast response to issues and changes, and that adaptability. Is that final product that we want to see?
It is, and the whole idea is that if you can catch a defect while you're making it, then you don't have to worry about adding value to a part that's going to fail a process further upstream. I like to use the example of DC tools and leak test all the time, because oftentimes, when you fasten a part to another part, there's some type of gasket or some, whether it's a liquid gasket or a hard gasket that's put in place. And the only thing that's making that seal is the compression of the fasteners when you torque them down. So, if for example, when you fasten those, when you do that fastening event, that you did not in fact achieve your end result, then you can fail the part immediately, rather than sending it down and finding that it failed at leak test and then having to take those other 6 processes in between. It's worth of value, and take them off the part to try to rework it. The very first bullet point up there, make it right the first time, it sounds simple. Everyone's working towards that goal, but if you aren't verifying that it's correct, then your first gate for did I make it properly happens either at some sort of end of line test or when it gets to your customer, and that's a really expensive place to find out that you did not in fact make it right. So
right, absolutely. Okay, so we've got customers that have this legacy equipment. They've got, say, a CTS leak tester, an old C20, and they've got an Ingersoll Rand torque gun. They've got a Promus press. All of these devices speak a different language. How have you found it to bring all of that data together and make it useful? What are you seeing out there? What's some of the lessons learned there as well?
Well, I mean, there's lots of different ways to approach that. In certain instances, you can be very, very rudimentary. You look at those different devices, they do all speak different languages. You might be using, discrete I/O out of a C20 to talk to a PLC. You might be using something else out of the ProMess press to talk to a PLC, but you can look for common threads. Is everything talking to a PLC, right? Is the PLC my interpreter, if you will? And what data could I send to the PLC? How could I get that out of the PLC? Because even though you might be using, different tools to do different processes, if they are talking to a PLC, then more than likely you've standardized on some type of PLC. You don't typically find Siemens, Allen Bradley, and Automation Direct in the same building. Sometimes you do,
right,
but not often, right? So, you can approach it from that perspective, looking at a way to bridge the gap between those things, and not worry so much about the language that they speak, and more worry about what they're speaking that language to. And just start small. You have a leak tester and a ProMess press and whatever else, Ingersoll Rand DC tool. Find out what data you can get from it, so that you can, there are tools out there. People have developed tools. We have one that we use through a third party as well, that are specifically designed to take advantage of some of the open communication protocols that exist within these tools, to be able to extract as much data out of them as you can. So even though at face value, they've all come from different vendors, they were all purchased at different times, they all do different things. At a more basic level, the ones and zeros that they can send out may still be perfectly accessible, so long as there's a tool you can use to get in and get that data. And people have made great strides in the last couple of years developing tools to sort of commonize the collection of data, if you will. Get what you can, so that you don't end up with what you don't want is to have, okay, I have a ProMess press and an Ingersoll Rand DC tool and a C20 leak tester. You don't want to have to buy something from Ingersoll Rand, something from ProMess, and something from Cincinnati Test Systems to be able to get the data from each of those individual things. You don't want to take one silo and create another silo of data, if you will. You want to try to get those things together so that you can spend less time hunting for data and more time using the data to make decisions. If that makes sense.
Yeah. So now you've aggregated the data what are you going to? So now we got to make sense of the data, right? So we're collecting.
Yep. Yeah. So we sort of think about, Factory 4.0 is a four-step process, and each of those steps has a whole bunch of subcomponents. But at a high level, it's got four basic tenets, right? Monitor your processes, um, collect and store that data somewhere. We always encourage people to commonize the repository of data. So don't go from well, I guess you could, but if you have 30 different collection points out on your manufacturing line that you want to collect data from, the idea would not be to take those 30 collection points and have 30 different spots that you're collecting data into, right? The goal is to sort of be a pyramid coming back up. So if you have a bunch of devices you want to collect data from on the plant floor, try to figure out how to get all of that data back into one spot, whether it's something simple to start with, like you've got a leak tester and you've got an Ingersoll Rand tool, and both of them are talking to the same PLC. Maybe you can write an interface to get the data out of that PLC. So now you're collecting it from one spot, and you can just look at it in Microsoft Excel, as a very rudimentary way to get started on understanding how the data can be collected and what the data is that you have. But yeah, you have to monitor your process, store that data, and the more succinct you can be in storing that data, the fewer silos you have with that data, the more step 3 starts to really make sense. So the whole point, like we discussed, is to report is to analyze the data so you can make better decisions. And if you're spending all of your time trying to analyze your data because it's in 7 different places, then you're not really being efficient with your time. You might still achieve the same end result, but you won't really be efficient with your time. So by putting it all into one spot that's easily accessible, you can do that analysis. And so now you can start to look at, how does this process over here affect this process over here? So you can start to look beyond just the one manufacturing station and look to see, how is my leak test doing? Well, it seems pretty good. Control limits are good and everything seems to be chugging along. Okay, great. But I do have some that are sort of outside my normal control limits. What's happening there, right? And so once you start to see where the trends are, you can start to look as you connect these stations together and get all that data together. You can start to analyze and look for correlations between things and try to help to understand, why do you have those outliers? Are they good or are they bad? So, and then,
so, I just want to mention to think about, to build on what you're saying there, as far as processes and their interconnectivity. So from a global perspective, if we're looking at a manufacturing facility that has machining as well as assembly, the goal, as I understand with Industry 4.0, and correct me if I'm wrong, is we've got the machining data, and based on that machining data, it can help us to understand defects that we see in the information that normally wouldn't be something that we would necessarily connect the dots from everywhere in the facility. That's part of the Industry 4.0 mission as well, right?
It is, yeah. I mean, there are a lot of things in your facility that contribute to defects that may not really even be part of your normal sphere of influence. So if you're tasked with a particular part of final assembly of a product, but your product happens to comprise several machine components that came from the machining portion of your plant, if their tools are chattering when they're making holes, or they're chattering when they're supposed to be creating a flat surface so that you can make two things together, if your part is supposed to be flat and it's tipped like this, there isn't a gasket in the world that's going to seal that off, right, when you go to put it together. So there's everything upstream from where you are right now contributed to whatever defect you find in that station. You didn't make it in that station. It happened somewhere else. So part of the the goal of Industry 4.0, as you've said, is to be able to look, by having all of those stations connected into a database that allows you to do quick analysis on it. You can start to understand, you know, okay, it seems like every 97 parts out of this machine, I start to see my leak rates go up over here. Maybe our tool is wearing out faster than we think it is, right? Maybe we need to do a tool change more often, or maybe something else, right? There's a lot of stuff that could be going on that could impact your downstream quality, and having access to all of that is really important. Even if it's not making defects, it can make it harder for you to find defects, because all of that noise makes it so that, yeah, it's still a good part, but now I have to increase my leak limit by, you know, it was 5 SCCM and now I have to make it 10 SCCM because I have to account for what's happening in machining. And every time I make that number bigger, I lose the ability to find small defects, right, and catch small changes in my production. So yeah, bringing all that data together, whether it's manufacturing data, or excuse me, machining data, final assembly data, you know, it's really important. And at a global level, as you said, being able to do that in one facility versus doing it in another facility can be really, really helpful, especially if you're producing the same component in several facilities. You know, you can start to look at how facility A compares to facility B. Do they have the same supply base? Do they have the same manufacturing processes? The same instruments that are doing the manufacturing? And you can start to get a feel for if there's, you know, common defects that exist irrespective of specific manufacturing processes. You know, we're using a ProMess press here and a Kistler press here, and we still have the same defects. So it's not the process, it's something else, right? Something else about these two press things is incorrect, and it has nothing to do with the fact that the press system is incapable. So we've tried 3 different ones now, and they all give me the same problem. So
yeah, I remember back in the day when I had to work for a living as a manufacturing engineer. Sometimes that chasing your tail would be so frustrating, because we'd assume that we knew what the problem was, but it turns out it was 10 steps away from where we were actually looking. So we're monitored. We've collected the data. Are we using Access, SQL? What's a normal repository?
It depends. In some cases, you know, a lot of our customers are using SQL databases, because you can download SQL Express off of your off the internet, and it's free and you can use it. It's, you know, it's not terrible. The Access is fine. Some people just have, you know, an elaborate series of Excel spreadsheets where they have a master sheet that's got macros that look, and they just take the CSV files from, you know, or text files from 3 or 4 different operations that they want to look at, and they just put them into a folder, and when you open up the spreadsheet, it runs the macro that pulls all that data in and creates your Pareto charts or your run charts or whatever it is that you're looking at. I mean, there's a lot of different ways you can do it, from, I'll call it lo-fi, up to, you know, super hi-fi. It really just depends on your needs and your comfort level with the different tools, and you know, how much effort you want to put into doing the analysis and versus the results of the analysis, right? So
we've collected it, and now we're reporting and we're analyzing, just like you said there. And that's, you know, that's the Sciemetric piece, right? So or actually, we're kind of at all areas, but the software that we're using to take that data and make sense of the data is very important, right?
It is, yeah. I mean, you know, there's lots of different things that there are things you're going to need to do with the data that you never imagined. And the nice
like
thing,
what would be an example?
Well, you may find that, you know, suddenly you need to, you know, you thought that you could get by with statistical process control stuff. So you've got your Excel sheet, and you've got your run chart, and you're looking at your sigma, plus or minus 3 sigma. You've got your skewness and kurtosis, and you've got your whole 6-panel, SPC chart up there, and you're doing great. But you're finding that even though you are within your process control limits, defects are still getting out of the plant, right? So what we often find is that people need to be able to do analysis that has nothing to do with statistical process control. They may need to do analysis on process signatures, right? So you may not have thought in the beginning that you needed to create a process signature. Industry 4.0, that's sort of the evolution of Industry 4.0, is having digital process signatures from sensors rather than just the final value from the sensor. And I don't think anybody's going to want to write an Excel spreadsheet that, can do, pulls in tens of thousands of data points to make a curve out of something. And then, if you had to write an equation that said, okay, now take all this, take the derivative over this period, save that as a value, and then graph that as it compares to the area under the curve. I mean, you'd spend a month writing that, and you'd still probably you'd be missing a parenthesis somewhere in your equation. It would all go to hell.
You're right. Yeah.
So, but the tools we have, QualityWorks, I mean, all of that stuff is built into it already. You can do sort of any mathematical process you want to anything that you want. And you can look for correlations, rather than trying to establish whether or not, does this have a good R-squared value? Do we have good correlation? You just simply pick the two things and plot them X versus Y, and it tells you what the R-squared value is. You don't have to be a statistician to know if it's actually the thing that's killing you, or if you thought it was the thing that's killing you, it actually has no correlation to what you're seeing at all. There are things that you will get into that you never really thought of. In the same way that, I don't know about everybody on the call, but I find myself every month probably trying to Google, like, how do you do this in Microsoft Excel? Because it's something that I know the capability exists, but I don't know how to do it. I've never done it.
Right.
There are a lot of those instances where people find that it's faster to use a software platform that has already envisioned what those needs are going to be, because either they were forward thinking enough to do it themselves, or because, in the case of like QualityWorks, the software program's been around for 35 years. So people have asked us to add a lot of features that over the years, like, hey, I need to do this. Hey, I need to do that. It doesn't do this. Can we make it do that? Yeah, sure. Why not? Let's put that feature in there, because if you're asking for it down the road, someone else is probably going to need it too. So we'll just get it in there now. So
sure.
It's, sometimes easier to start from a known commodity and let us help you to do that analysis, show you how to use the tools to save yourself some time. So.
Yeah, so excellent. Appreciate all that. So we've talked about from a global perspective. Now, if a customer wants to begin this process, and where should they start? And that's kind of what you've got here on this slide. So let's talk us through this.
Yeah. So from a where to begin perspective, I think I took the approach of if it were my facility, and I was a new engineer stepping into a place that I had no part of designing or implementing or anything else. I'm just, here I am, I have to make good parts. My first step is always to assess where you are today. So when I go to customers and they ask for help from us, one of my first questions is, can you please show me a defect Pareto? Can you show me what your top 10 defects are in your facility right now? Printed out most people have a defect Pareto that they're looking at on a daily or weekly basis. Show me a defect Pareto for the last 6 months. Do you consistently see the same things on that defect Pareto? Are your top 5 hitters always the same? Looking at that data, and then looking at what you have identified as processes that are critical to your own quality. So most manufacturing facilities, if you're building an engine, for example, one of the processes that is always critical to quality is crankshaft torque to turn. You put the main bearing caps in, and you turn the crank to make sure that you haven't missed a bearing cap, put one on backwards, or have some debris in there, right? Like, there's a whole bunch of things that can kill you, and the crankshaft might be one of the most important parts of an engine. So, you know, a lot of people have those critical to quality stations. So look at those critical to quality stations, look at a defect Pareto, and look at your warranty information, and sort of make a Venn diagram, if you will, of those 3 bits of information. And what you'll probably see is that in some of the stations that you've defined as critical to your quality, you have no data collection whatsoever. So you're assuming that process is working the way it's supposed to. In some stations, you'll find that even though you haven't defined it as critical to your quality, it happens to produce 90% of your defects. So looking at that and then looking to see what data am I collecting from that, you know, you may have a whole new understanding of what should be considered critical to your quality based on the data that already exists in the world, right? The warranty data is the thing that you're trying to get under control typically. That's the first place people start is, I need to minimize the amount of money I'm spending on warranties. How do I do that? And then I think once you sort of have an understanding of that, the other thing you have to do is, everybody has processes that are meant to catch defects. So leak test is a great example. Leak testing doesn't add value to a part. It tells you if the part is good or bad, right? It's a gauge. Just like if you have a machining process, every once in a while you take a part, put it in the CMM room, and you hit it with a Zeiss, and you go, yep, it's the right dimension, matches the print, process is still good to go. That leak tester, or any of your go, no-go gauges, has to be assessed on an annual basis. So I have been in facilities where they have stations which are critical to their quality that are not being monitored, and gauges which are designed to catch defects made in those stations that have never been checked. They were put in 15 years ago and they've never been verified, and they are essentially blind, and they're producing defects, and their warranty is, you know, unsustainable, and they want to get it under control. So one of the things in that assessment that you just have to be honest with yourself about is, are the gauges that I have put in place to verify that I have done this correctly, when was the last time I checked that they're actually capable, right? And sort of understanding where you're at. You may find that you're in great shape. You might find you're in really bad shape. And of course you can be anywhere in between, but understanding the capabilities of your manufacturing process as it exists today, that snapshot, is critical to figuring out where you need to go with it.
You were telling a story. You were telling me a story earlier. We're talking about Cummins, and in an instance where you were able to apply this strategy. Can you talk about that some level?
Remind me what, I feel like there's a bunch of
yeah. So we were talking about leak tests, and so I was asking you earlier about an example of, you know, taking a process. You've got multiple locations and really digging deep and making some analysis and then changes.
Yeah, so one of my largest customers sort of had this scenario whereby they didn't want to be heavy-handed at a corporate level. They didn't want to dictate processes to plants. They thought that if we allow the plants to investigate the ecosystem of what's possible for in-process testing and verification, that, you know, what's the best in North Carolina may not be what's the best in New York versus what's the best in India or what's the best in China. So giving the autonomy to the plants to determine how best to check their parts for defects. And so in this instance, we're talking about leak tests, and they had, you know, they got to a point where every facility had what they considered to be a world-class leak test system. But every year, their leak-related warranty got worse and worse and worse, both on a PPM perspective and in terms of dollars. So it didn't matter if they were making more product or less product, it was getting worse by every metric, it was getting worse. And so what they found when they took that step one assessment was everybody's process was different. Not just in terms of the equipment they've purchased to do the process, but people were testing things at different pressures. They were looking for different leak rates. They couldn't tell you where the leak rate came from that they've selected. They couldn't tell you when the last time they checked the gauge was. You know, one of the most critical parts to any gauge process is passing a gauge R&R, right? To understand capability and reproducibility, you have to be able to tell if you can catch a defect. And most people hadn't done that well, most people couldn't even tell you when the last time they had done that was. So when they finally said, okay, let's start there. Let's take a look at, everyone's doing it differently. That's cool. I'm okay with everyone doing it differently for now if everybody's process is capable. So I want everybody to go through a gauge R&R and tell me where we're at. And what they found was sort of exactly what they expected to find based on the warranty value that they had, was the gauges are simply, they're not capable of catching a defect. I can put an engine in there with a defect I know will fail hot test, and 1 time out of 6 it catches it. And I put it in another station and it never catches it at all. Like, it's just not capable. The system is incapable of catching defects. And this has been our primary method for making sure that those defects don't leave the building. So, you know, what we did for them was we tried to understand not just how to make the system more capable, but also help them understand how should you be testing this part in the first place? You know, what defects do you feel you should find here? Because some of the defects that they wanted to find at that leak test station, you couldn't do. It wasn't possible. And so what started off as purely a leak test intervention, if you will, turned into a leak test plus philosophy. So you can do leak test, and here are the 50 defects you want to catch at end of line leak test. And here are the 14 that you can actually catch at end of line leak test. These other 36, you have to go upstream. You know, you can't see if your crankshaft is leaking at end of line leak test. There's too much other stuff in the way. There's too much noise. The turbo is leaking. The exhaust manifold is leaking. Those are always going to leak. You can't see the defect at end of line, but you can see it right after you install the crankshaft. That's where you have to do the leak test if you want to catch that defect. Some of these other things that are contributing to your leak limit that's really big, those are process-related problems. You're using pneumatic tools instead of DC tools. So yes, you're gaining speed in terms of the rundown, but you're losing fidelity in terms of the consistency of the fastening, right? You can't interlock a pneumatic tool to say, do this one, then this one, then this one, then this one, and have the PLC say, we're good. It's not capable. You can't do it. And so all of those things stacked up to an end-of-line process that was both incapable of catching defects, and, you know, even if it was capable, the limits were often so large that any defect that would have been caught was sailing right through, because they had set their limits around what their production capability was. But the production capability wasn't there either. So, you know, we helped them to take a look at what they could catch and what they couldn't catch, and for the things they couldn't catch, how to catch those further upstream, and the results have been phenomenal. I mean, in certain facilities, we've seen warranty reductions by as much as 80% in the first 6 months of those leak test solutions being in place. And part of that leak test solution was, look, you're going to generate a lot of data from leak test now. So let's get it into a spot where you can look at it. And let's get some of these other processes. Let's get your DC tool data. Let's get your vision data. Let's get all that stuff into this database so that when you see a leak at end of line leak test, you can go look at the image from when you put the form in place gasket on the oil pan, and you can say, oh, well, there's a huge spot where there's no gasket. Is that where I'm? Well, of course it was going to fail. I should have been able to catch that back there. So, you know, it's been really transformative for them in terms of both the visibility into their process and the ability to reduce their warranty. And yeah, it's been a phenomenal experience to see them really latch on to what the data can tell them about their process. And it's been really good. So Yeah, and one of the things I want to impress upon people is certainly the example I gave is sort of a if money is no object sort of example, which it is for most people. So um, there's probably a lot of, as part of step 2, I think one of the things that your Venn diagram will show you is there's probably a lot of data that you're producing in your facility right now that you're not capturing. If you have cameras, they're taking pictures. Where are they going? Right? If it's a Cognex or a Keyence camera, it's going nowhere unless you tell it to. But you can tell it to, right? And so that's an important feature. Tell it to go somewhere. Don't just let it erase it and take another picture, because then you have no idea what it looked like before you sent it on. So there are probably what I would consider low-hanging fruit in terms of data that can be collected, because you're already making it. You're already producing the data. So just give it a place to go. That'll help you understand where your gaps are, right? And then I always tell people to start small. So start with pass-fail data. If you're already getting pass-fail results, then go on to scalar data. If we continue on with the leak test example, scalar data would be final leak result, final test pressure, date and time, serial number, model number, things like that. Things that allow you to slice and dice the data so that you can look at it how you might want to. I look at my failure report and I find that I have 27 parts that have failed leak tests today. So then I sort by model type and find out that 95% of them are one model. Okay, well, that's good information, right? That gives you a place to go look. So I don't have to worry about this one so much. For some reason, this one's different from this one. So I need to try to understand why it's different, because it's the one that's contributing to my overall problem. And what that'll tell you is, it'll give you a little bit clearer picture of your data landscape, right? So now you're getting some scalar values. You'll do the work with the scalar values to help understand your process. And what that will inevitably lead to is this realization that for some things, scalars are fine. For other things, I have every scalar value you could possibly imagine, and I still can't catch my defect. So what do I do now, right? And that's where you start to look at modifying the process by adding additional sensors, adding additional data collection, so that you can get these digital process signatures, these guys here, right? Mm-hmm. We like to talk about them as like an EKG, right? Your heart does the same thing every time it beats. And so that's why your doctor can take a 3-second snapshot of your heart and say, looks good. Or take that same 3-second snapshot and go, well, Russ, I'm be honest with you, everything looks good except this tiny blip right here. Nobody else's heart does that. I'm not a cardiologist, so I don't know what that means. I'm gonna send you to someone who sees stuff like this, and they can tell you what it means, whether you need to worry about it or not worry about it, right? Mm-hmm. So having that data is critical. The defects live in these process signatures. Every defect you make is in that process signature. So once you have those process signatures, you have all the information you will ever need to be able to separate good from bad. And that's where, getting that information into a place off your plant floor where it can work for you really is the last part of step 2. You've got to get that data up somewhere so that you're not out running around. I had a customer who had, they made dispense equipment, and they had a whole bunch of manufacturing data that was being collected, but it was in a whole bunch of different databases all over the plant. And they paid someone full time, 40 hours a week, to do nothing but go around every day and get that data, aggregate it together so they could come in on a Saturday and get paid overtime to analyze the data so that the reports could be ready for Monday for the managers to see and figure out where their problems were. Where do we need to spend our time?
Wow.
And all because they didn't want to put it into one spot. All of those databases could have easily sent their information to a collecting database that would have allowed them to do what that person was doing in a 50-hour work week. They could have been doing in minutes, hours, and had access to the data in almost real time, versus by the time Monday comes around, you're looking at where you were last week, not even where you are right now, right? So So that's kind of step two, and then step three is, I guess is encompassed in there a little bit. Once you have the scalar values, they'll tell you where you need more. Where do I need more data? And that's where you add sensors and other data collection to see into the areas where you were blind previously. And then the other thing I like to stress to people is that we're talking about examples right now where people are dealing with equipment that they already have, right? Leak testers or press systems or whatever, stuff they already have. That's fine. Those are things you have to live with. Going forward, though, as you look at capital purchases, the ability to produce and distribute data out of those tools has to be part of your decision matrix for any new capital equipment. If you have a piece of equipment right now that you know you need more data out of, and you get the green light to replace it, and you buy a piece of equipment that can't give you any more data than the one that you had already, shame on you, because you're gonna have to wait until it depreciates now until you can get the piece of equipment that could have actually made your life easier. So once we see people starting to collect this data, it becomes a critical piece to all of their capital purchasing. In fact, it drives capital purchasing. In some of our customers, they simply will not buy a piece of capital equipment that cannot push data into, in this case, QualityWorks. If it can't push data to QualityWorks, it's off the table, not considered. So,
excellent. Yeah, I'm going to add that. So I do last week we had a conversation about creating I call it the ultimate request for quote. Essentially, there is a decision matrix that you want to put together. Data was not one of the decision points that I had in there as an example. So I'm definitely going to add that as part of that discussion. So thank you for that.
Yeah, no. So, and then, if we go to the next slide, the last slide that I have here is sort of giving an example of when we think about data, the system you want to collect that data should be agnostic, right? So there are lots of companies. If you have Atlas Copco DC tools, Atlas Copco makes a system called ToolsNet that can collect all the data from their DC tools. And it does a great job for data from DC tools. You get process signatures, right? You get scalar values. It's great, but it only does DC tools. So you can't put your leak test data into it. You can't put your vision data into it. You can't put your functional test data into it. You've gone from one silo to another without really, affecting your ability to do correlation. So what we tell people is you want to pick a software platform that allows you to do a couple of things. Firstly, get data from anything. If your manufacturing process only consists of DC tools, okay, I haven't seen one of those yet. So make sure that you can collect data from anything, right? PLCs, cameras, DC tools, leak testers, the thing you don't even know about yet, everything, right? The second thing is understand that, we talked a little bit earlier about software that allows you to get, let's see if I think I can draw. I can. I think I can draw.
So as you're figuring out, the drawing portion of that, one of the challenges that I've seen customers experience is with Atlas Copco as an example. So they've got ToolsNet, and they will tout ToolsNet as a great place to collect your data, analyze your data. But the challenge with that is that ToolsNet doesn't play well with others. And so to get that information out and use it in a bigger analysis is very challenging and can be. I've had many customers frustrated because of the proprietary nature of some of these different softwares that these companies have available, or tout, and then you can't use it.
Right. Yeah. I mean, the access to data is a critical part of collecting it. So, one of the things that we tell people is sort of buy anyone, anytime, anywhere. That's the philosophy we want to try to instill in people with the data they're collecting. So if most other data collection system. So if you have an ERP system or an MES system or some other type of enterprise software package that you're using, they were never conceived to handle process signature data. They were conceived to handle scalar data. So, but all of the scalar values that you might want in those things exist within the process signatures you're collecting. So collecting all of that into QualityWorks and then letting QualityWorks distribute those things out to your MES or ERP systems is a perfectly fine way to use the software, right? Most people's warranty data exists in MES. So if you can do queries in your MES system that looks at warranty and looks at the scalar values coming from the plant floor, you can start to draw correlations between, like, okay, well, we still have a lot of leak related warranty, but I'm getting a first time right in station that is very high. So there's something about this that's incorrect. Something about this just fundamentally doesn't make sense. So it gives the quality team an opportunity to go back to the manufacturing team and say, I need you to dig deeper into this. There's a mismatch between what the data I'm seeing in MES shows and what our warranty data shows. Can we collect some more data from this station? Do you have additional data? Do you have process signatures that would help us understand why this is the way that it is, so that we can try to get our arms around it? But yeah, sharing the data is critical. Being able to, you know, the number of times that I've been in a hotel room in another country looking at data, you know, on a server halfway around the world and doing analysis with people, I can't even, I mean, I don't have enough fingers to count, you know. That's the whole point, is people are mobile. Well, not today, they're not, but they were a couple of weeks ago, right? And the world is small and people are mobile. So as you move around, not that you want to be bothered at the airport when you're just trying to have your coffee and read your book, but you should have the capacity on your laptop to be able to open it up, get on your VPN, connect to a database, and have someone, because someone has called you and said, we've had 12 failures through station and nobody knows why. And our boss is telling us we need to stop the line. Can you help, right? This is, you look at this stuff all day long. Can you help me? And, you know, being able to get to that data and look at the real-time data and look at all of the process signature data. That's what Industry 4.0 is about, right? Access to all of this new immense data so you can make a better decision as to what's happening. That's the...
Well, one of the, as we move closer to realizing the Industry 4.0 vision, it's facilities connected, right? So it's a facility that's gathering the data, that is analyzing that data, but also that facility connected to another facility, and based on one facility's ability to produce is going to drive the manufacturing process at another facility. So it's from a even bigger perspective, you know, Industry 4.0 is connecting those different facilities and making manufacturing decisions based on data and information from one facility to another, and that's, you know,
Yeah, and it gets even, sky's the limit on where you want to go with this stuff. I was on an airplane before we weren't allowed to be on airplanes with a gentleman his software company helps people to optimize their supply chains, right? So you think about some of these large global customers, the automotive OEMs, right? Where you have pieces of those cars coming from all over the world, right? Multiple supply chains feeding into the same thing. And the idea that if you, for example, as you are building the car, if you started to see, or even let's go backwards from the car, something that still has an engine, still has a lot of components from all over the world. The cylinder head could be made in India, the block could be made in Mexico, whatever, right? If you could identify that you've had 5 failures or 6 failures or some number of failures in a row, and you can root cause that quickly and say, there's a problem with the castings coming out of our India operations. And that data could get fed back into your supply chain, and the orders going to India to feed your incoming plant could get routed to Mexico instead, so that plant you could shift production so that until you can understand what's happening in this one facility and get your arms around why the castings are bad, you can eliminate incoming defects and push them off somewhere else without impacting your production at all.
Mhm.
right?
Yeah, and it sounds like a dream, but that's where it's going, right?
Right.
That's the mission of Industry 4.0 is that connectivity, that ability to shift and change and adapt rapidly to minimize manufacturing interruptions and ensure maximum efficiency, right? So it's that next level of efficiency that these companies are looking for.
Yeah. And the nice thing, at least for right now, is, a lot of the stuff that we're talking about, you'll hear people talk a lot about AI and artificial intelligence and machine learning to do a lot of this stuff, but um, some of that will come into play. But when it gets into the actual engineering analysis and helping to understand what's going on and looking for root causes, machines aren't going to be able to look, they look for patterns.
Hmm.
These aren't patterns typically that you're trying to find. So there's a very human element associated with going in and analyzing the data. And to me, it's nice because it sort of helps me understand that there will always be a need for people who understand sound engineering principles and have an analytical mind. And if that's the sort of customer or person that you are, like the world is still there for you. Like your role is getting even more important in the world as people start to collect this data. You're going to be their guru, right? So it's a really interesting time to be in manufacturing, I think, and I'll be really interested to see how people latch on to this idea and how long it takes for them to really gain steam. I mean, we've been talking about it for 3 years now, and we're still just we're on the cusp of what's possible. There's so much available that we haven't even tapped into yet in terms of data and what you can do with it. So
Yeah, it'll be very Star Trekky as we continue to progress. It'll be amazing. It's going to be fun to watch as
yeah,
it all gets connected. One of the things we talk about in this Industry 4.0 discussion is production on demand. So we want it how we want it. So the consumer is going to be able to order their specific car, as an example, and it'll be the color that they want. It'll be the interior color that they want. It'll have all of the bells and whistles that they're wanting, and but that's an automobile, but that'll also happen for coffee cups and hats and clothing, and it's really that's what they're talking about, from a bigger perspective, is we all want it the way that we want it, and that individualization is going to be more and more prevalent um,
and
as processes get better at adapting.
one of the things we didn't really touch on yet today that I think is also really interesting as it pertains to this is, we've been talking about data on your manufacturing floor that affects your manufacturing process, right? But there's a lot of data that is not on your manufacturing floor that affects your manufacturing process, right? There's a lot of data inside your factory that is also really useful to you. If you have a leak test process, for example, I was in India earlier this year, and I was looking at a customer, and they were going to put an end-of-line leak test station in. It gets hot in India, by the way, super hot.
And a
And
little
they're
humid sometimes too.
just a little, yeah, just a little bit of that. And they were going to put a leak test station. They found the spot. This is where it's going, right? Okay, cool. It's right in front of an air conditioning unit. So, but the technology exists today to be able to do one of two things. Obviously, you can take the very analog approach and just say, can you move it 12 feet that way so you're not blowing cold air on this all the time? The answer was yes, but there's another air conditioner 12 feet that way because it gets hot in India. So instead, what they're going to do is monitor ambient temperature, monitor part temperature, and interlock the HVAC system to the PLC so that they can turn the AC system off when an engine comes into station so you're not blowing cold air on it, do the leak test, correlate for the residual cold air that's in the air so they know how much that's affecting their result, kick the engine out of station and turn the AC system back on because their throughput is low. They're only talking about, their cycle time's around 20 minutes, 20, 25 minutes. It's low. So they can do things like that does not impact comfort, but enables them to have a much better test. And the only reason that's possible is because you can collect that data and do something with it. right? And then you start having conversations about, well, okay, you know, could I take these same tools that are analyzing these processes on the line, and could I monitor the conveyor that's delivering the part to station to know when it's on the cusp of breaking? Could I look at the HVAC system to know when the fan is about to stop, you know, because I can use an accelerometer and the same, you know, FFT that I'm using to tell you if my torque to turn is okay, I can look to see if my fan's about to break. Because if that fan goes out and I lose my AC system, I can't machine parts because my building will be too hot, right? Like, you can start to use these same tools to expand what manufacturing means into more of a whole building perspective, but using, again, the same tools, same software, same type of analysis that you're using to make good parts, to make a good part producing facility, and make sure that you are always out in front of potential maintenance nightmares, if you will.
Yeah, that's very, very interesting. Well, you have been gracious with your time. We have probably just scratched the surface of this Industry 4.0. In closing, Aaron, you know, how can people get a hold of you, and you want to tell us a little bit more about Sciemetric?
Sure, yeah. I mean, you can reach me, you know, I guess, I don't know if you want me to give people my contact info, but obviously all of the guys at CapEx have access to us here at Sciemetric. To me, I interact with them on a pretty regular basis. But Sciemetric is, you know, as a company, this is what we were founded on, right? When we were founded in 1981-ish, the idea of using process signatures to help people find problems that's what the company was founded on. We existed in an almost purely R&D space at that time, because at the time people believed that was the only place you had enough time to do that type of analysis, right? And it was complicated, and the software was complicated, and, you know, it was 1980. I mean, everything was hard, right? So you know, over the years, we've taken those first principles and we've tried to make them simpler and faster to deploy throughout your entire manufacturing process. And along the way, we've discovered that you have to have a place to put all of that data, and you have to have a place to, you know, ways to access all of that data. And, you know, the sensors are getting better. You have to be able to sample faster. You have to be able to do all kinds of things that people are going to need to do. And so the products have evolved. You know, if you look at the SIGPOD that we produce today, I don't have one around me, but it's our data acquisition system. It's, you know, it's this big. When we first started, it was, you know, it was this big, you know. The next generation, which I also don't have in front of me, fits in the palm of my hand, and does all of the same stuff faster. So, you know, we're a company we're a solutions-based company with a wide breadth of knowledge when it comes to in-process testing, verification. Almost everybody in our company, from an application engineering perspective up to senior management, is an engineer that's been in the industry for as long as you can possibly imagine. And this is what we do. We help people, you know, take a stepwise approach of, you know, you've come to us because you have a problem. Let me show you how I can help you catch that defect, fix that problem, improve your process. I'll show you the way. If you're ready to go there, we're ready to help get you there. But this is the way. This is the way, the only way that is going to get you where you need to be. It's not always, you know, one of the things we pride ourselves on as an organization is not being. I present solutions to people all the time that I don't sell. So, you know, I'm very candid with people. As a company, our culture is we've been bred to be candid with people. You know, we'll do this analysis for you, and at the end of it, I'm going to tell you that, you know, these 11 defects that you want us to find with a leak tester, you could do that. Is it the best way to do it? No. Like, you should just use a camera in that station over there, and you could find most of them, and it would be, you know, a quarter of the price. If you need some recommendations on who to talk to about cameras, I'm happy to do that for you. Just, you know, this what we're offering could work, but it's not the best way forward. So in the spirit of data and information, we try to be very forthcoming in the information we provide to to our customers, to make sure that they get the best solution possible. And I think that's why, most of our largest customers have been with us almost since the beginning. They latch on to the technology and what it can do for them, and the technical expertise and the candor that the company provides. And we develop partnerships that never go away. So
That's awesome. Yeah, that always says a lot when you've got customers that you've dealt with for years and years and years and years. It says a lot about our companies when they do that. It's really about serving. That's why we're doing this industry cast, is because we want to serve. We want to help to serve our customers by providing them with hopefully useful information that can help them improve their manufacturing processes, improve their careers. Our mission is to help. We always want to be adding value. So you've added a lot of value today, Aaron. Again, very appreciative of your time. And my name is Russ Sorrells. We've got Mike Dorsey in South Carolina. We've got Chris Mullins in Eastern North Carolina, as well as Virginia. And then we've got Adam Hooper over in Western North Carolina. And Vicky Meza, she's the one that makes it all happen. She is the glue that keeps this thing going. So appreciative of all customers, appreciative of you, Aaron, and we'll look forward to catching up with you soon.
All right. Thanks, sir. Appreciate the opportunity.